Morning everyone, I am Saujanya. Today I will explain three important topics from theory of computation. The first one is all about acceptance of a Turing machine, second languages of a Turing machine, and the last instantaneous description. Before that, let me briefly recall what a Turing machine is. A Turing machine is a mathematical model of a computation. It has states, an input alphabet, a tape alphabet, a transition function, a start state, and two special states called accept and reject. This model helps us to understand what problems can be solved by computers. Then let us begin with the next slide of the PPT. Machine is have a 7 tuples m equal to q summation tau delta q naught a and b, and below q represents a set of states, summation represents input alphabet, tau represents tape alphabet, delta represents transition function, and the start state will be represented by q naught, and the last a and b represents halting states. Then next slide is about the detailed explanation of acceptance. Here, a Turing machine accepts a string when it enters the accepting state and stops. This means the machine has successfully processed the input. Acceptance basically means the machine reaches the accept state during its execution. Then the next slide is about the difference of acceptance, rejection, and the looping. There are three possible outcomes of a Turing machine. First, it can be accept the string by halting in the accept state. Second, it can reject the string by halting in the reject state. And the third, it might run forever without stopping. This is called looping. In looping, the machine does not accept or reject, it just continues. And the next slide, it represents languages of a Turing machine. Here, the languages of a Turing machine is the collection of all strings that it accepts. If the machine accepts a string, then that string belongs to the languages of the machine. We write this as L of M. These languages are also called recursively enumerable languages. Then let us begin with next slide. It can represent recursive languages. If a Turing machine halts for every input, either accepts or rejects, then the language is called decidable. If the machine halts only for accepted inputs but may loop on other inputs, then the language is recognizable. All decidable languages are recognizable, but not all recognizable languages are decidable. You can see an introduction of instantaneous description. Instantaneous description, or ID, is a snapshot of the Turing machine at any one moment. It captures three things clearly: the tape contains the position of the head and the current state. It helps us track how the machine is working step by step. We write an ID in the format alpha, beta, and gamma. Here alpha shows the tape content to the left of the head. Beta is the current state of the machine, and the last gamma shows the symbol under the head and everything to the right of it. This notation makes it easy to represent the machine's condition. And the last, it's all about important of theoretical part. Theoretical part, we can see every decidable language is recognizable. Then There exist recognizable languages that are not decidable. Next, complement of a recognizable language need not to be recognizable. And the last, a language is decidable if both it and its complement are recognizable. It's all about my presentation. The Turing machine accepts a string if it halts in the accept state. The language of a Turing machine is the set of all strings it accepts. Instantaneous description gives a clear picture of the machine's tape, head position, and current state. At each step, these concepts help us to understand how computation happens theoretically and how machines solve problems. Thank you for listening, and I hope you all enjoyed learning about a Turing machine.